right now, as you hear my voice. Your heart is beating almost 70 times per minute. You can see, you can hear, you can speak. But have you ever thought, what if your heart stopped right now? No warning, no sound, just one final heartbeat, and then silence. A moment ago, it was beating, and now it's not. Let's start from the beginning. When your heart takes its final beat, you don't feel anything. There is nothing that you can immediately notice. Your blood pressure drops to 0. The 5 liters of blood that were circulating through your body suddenly stopped, because now there is no pump, no flow, no fresh oxygen is reaching your organs. But here's the thing, your brain doesn't know that yet. For the first 10 seconds, your brain is running on the remaining oxygen in your blood. Your neurons continue sending electrical signals. Your thoughts continue. Your memories remain intact. Technically, you are still you. After about 10 seconds, things begin to change. Your brain, which uses about 20% of the body's oxygen, begins to realize that the oxygen supply has stopped. Suddenly, it enters a state of severe oxygen deprivation. The cerebral cortex, the center of consciousness, awareness, and thought, begins to slowly shut down. Your vision starts to fade, your eyes stop seeing, your ears stop hearing sounds. The world slowly slips away. From the outside, you look gone. But from the inside, something very different might be happening. Research has shown that when oxygen levels drop, the brain may produce one final burst of extremely powerful activity, one final wave. Scientists have observed intense gamma waves during this stage. These are the same brain waves associated with consciousness, memory, dreams, and mental experiences. Some researchers believe this may explain why people who are revived after cardiac arrest often describe remarkable experiences. A bright light, the sensation of floating, or memories they had forgotten years ago. And interestingly, these memories are often not life's biggest moments. Not an award, not an achievement, but ordinary moments. The smell of rain, the blackboard of a school, a conversation from years ago. Moments you thought were gone forever, yet somehow your brain kept them stored away. About 30 seconds after the heart stops, blood is no longer carrying oxygen anywhere. Approximately 37 trillion cells suddenly become deprived of oxygen. Without oxygen, cells switch from aerobic respiration to anaerobic respiration. It is an emergency backup system. It still produces energy, but it also creates lactic acid. And that acid begins accumulating throughout the body. Your muscles stop receiving instructions from the brain, your jaw relaxes, the tension in your eyelids disappears, your pupils dilate, and they stop responding to light. The eyes remain physically present, but the consciousness behind them is fading away. Within 25 to 30 seconds, brain activity drops dramatically. Neurons make a final attempt to survive, but their fuel is almost gone. After 3 to 5 minutes, brain cells begin to suffer irreversible damage. The organ that created your thoughts, dreams, fears, personality, and lifelong memories slowly falls silent. Meanwhile, the lungs have stopped breathing. The kidneys can no longer filter waste, the liver survives a little longer, but eventually it too begins to fail. Now every cell in your body is making one last attempt to stay alive, but time is moving quickly. After about 1 minute, you enter a strange biological state. Not fully alive in the traditional sense, but not yet completely beyond recovery. If someone starts CPR at this moment, or a defibrillator restores your heartbeat, many of your cells can still be saved. The process can still be reversed. Every day, many people return from this state, because death is not always a single moment. Sometimes it is a process that takes time. But if no help arrives, the countdown continues. A few hours later, the body begins to cool. This process is called algor mortis. Body temperature gradually approaches the temperature of the surrounding environment. At the same time, gravity pulls blood toward the lower parts of the body. This process is called livor mortis. After 2 to 6 hours, another change begins. The muscles start to stiffen because the cells have completely run out of energy. The muscles contract and become locked in place. This condition is called rigor mortis, which usually reaches its maximum intensity after about 12 hours. Meanwhile, powerful enzymes inside the cells, which were previously contained, begin to leak out. They start breaking down the cells themselves. This process is called autolysis, meaning self-digestion. Your body begins dissolving itself from the inside. By the end of the first day, the process spreads further. Tissues begin losing their structure. and cells continue breaking apart. After 2 to 5 days, the billions of bacteria that once lived peacefully inside your intestines begin spreading throughout the body. They break down tissues, produce gases, and accelerate decomposition. The body begins to swell. Its color starts to change, and internal organs begin deteriorating rapidly. After a few weeks, the skin loses much of its strength. Between 1 and 6 months, most soft tissues gradually disappear. Muscles, fat, and organs become part of nature's cycle. The body that once walked, spoke, laughed, loved, and dreamed begins losing its physical identity. After a few years, mostly bones remain. But beneath the earth, time continues its work. Moisture, acidity, bacteria, and fungi gradually begin breaking down the bones as well. Between 20 and 50 years, the bones weaken. Cracks begin to appear. They break into smaller and smaller fragments until even they lose their identity. Calcium, phosphate, and all the minerals that were once part of your body return to the earth. Eventually, only atoms remain. Your body returns to nature,